So I will mark through these, and I'll put this up on YouTube so that y'all can see that. Okay. So the term for charge of an ion. This is one of the vocab words that you all need to know. This is oxidation number. The oxidation number is what we put at the top of the periodic table. So if you remember your valence electrons, everything in group 1 has one valence electron. So it can gain 7 or lose 1. It's going to lose 1. If you lose a negatively charged electron, you become positively charged. So the charge or oxidation number of everything in group 1 is positive 1. Everything in group 2 has an oxidation number of 2 plus, because those are going to lose 2 electrons. We're going to skip the transition metals. And I like to, when I come over here, I like to put a little 0 above the noble gases just to remind me those are not going to form compounds. They're not going to get oxidation numbers. Everything in group 17 has 7 valence electrons. So it's going to gain 1. If you gain an electron, you get a charge of -1, so the oxidation number is 1 minus. These have 6, so you're going to gain 2. So I did the positive 1 and 2 on the left, positive 1 and 2 on the right. Let's continue with the 3 minus, which means over here, this is a 3 plus. And now in the middle, this is definitely a 4, but is it positive or negative? You're just going to have to memorize this one. Experiment shows that it is always positive. Are there ways to force it negative? Yes, it takes more energy. We're not going to bother with any of those. So these numbers across the top are called oxidation numbers, and you should know those. Okay? And if you don't have those memorized, which is pretty easy if you write on the periodic table, then you don't need to. Then you need to figure out how by figuring out the valence electrons. Okay. All right. When writing the formula for an ionic compound, you always write the cation first. The cation is the positively charged ion. Okay. The oxidation number for oxygen. If we come back to what we just had, oxygen is over here. It's in group 16. The oxidation number is -2. So the oxidation number for oxygen is -2, or technically it's 2 minus. I'm not as picky on that with physical science, but I am in chemistry, whether you put the positive in front or the back. Okay, next question, what is the oxidation number of calcium? So if I look at calcium, calcium is a metal. Its oxidation number is +2. So calcium has an oxidation number or charge of 2 plus. Excuse me. The oxidation number of silicon. We're going to go back to our periodic table. And I'm just going back to where we drew on it. Silicon is right here, and that's oxidation number is +4. So the oxidation number for silicon, 4 plus. Oxidation number for everything in group 17, that's the ones next to the noble gases. Those all have a charge of 1 minus. So everything I just did there, you have to be able to do. Okay? The positive ion is called the cation. The anion is the negative ion. The formula for potassium chloride is going to have to be gained from, there we go, I forgot it. From here, we have potassium is +1, chlorine is -1. So if I come back here, we have potassium, okay, using the mouse, sorry, and chlorine. We write the oxidation numbers. And then I get ready to write the formula. So we have KCl. And then you should recognize that we're always trying to make the compound neutral. So positive 1 plus a negative 1 is 0 or neutral. So you only need one of each. That's why it's KCl. This KCl is totally wrong. Let me clear it so you can see it. Because it's got a capital L. Think of the symbols as symbols, not abbreviations. Capitalization does count. If you put capital C, capital K, capital C, capital L, it will be marked wrong because that's not potassium and chlorine. Okay? That's potassium, carbon, and a non-existent atom. So do make sure that you have that right. Aluminum oxide. Aluminum is positive 3. Oxygen is negative 2. Notice how I keep jumping back and forth to the periodic table. That's where you're going to find your information. So aluminum, I said, was positive 3. Getting slightly better with the mouse. Oxygen is 2 minus. Yes, for you artists, I do have a Wacom tablet, but it's at home. I thought everything would work. And then we're going to do our crisscross method. We're going to take this 3, and it becomes the subscript for oxygen. A subscript simply tells you how many atoms we have. Do not put a charge for the subscript. I think some of you are on your phones instead of listening out there. I'm telling you what you need to know. Put our phones away, please, in the back. Thank you. The 2 is going to come down right here. And we have 2 aluminums and 3 oxygens. If each aluminum is 3 plus, and we have 2 of those, that's a positive 6. If each oxygen is 2 minus, and we have 3 of those, that's a negative 6, which makes it neutral. So use your crisscross method here. Calcium sulfide is slightly tricky. If you look at your periodic table, calcium is 2 plus. Sulfur is 2 minus. Wow, that's actually a good S. Looks upside down, but for a mouse. So looking at this, you should be able to say, oh, they're the same charge. I only need one of each. So this is going to be neutral, just CaS. But if you do the crisscross, you would end up with Ca2S2. And in that case, you have to cancel or reduce those subscripts. Okay? All right. Formula for calcium fluoride. Calcium is positive 2. Fluoride is negative 1. So you need one of the positive 2s and 2 of the negative 1s. So CaF2 is what we're talking about here. I used to, this one right here, CaFL2, is one that students would put. And I used to say that there is nothing on the periodic table that's FL. It's just F for fluorine. And my daughter took chemistry last year and was getting mad at me because very clearly there was an FL. It's one of the new elements right here that they announced the names of them last year. So if I fuss at you and say there is no FL on the periodic table, you can go, yes, there is now, because that's new as of last year. Okay. The next one, what is the formula for sodium chloride? Sodium is +1. Chloride is -1. Let me do this so you can see that. So we have one of each. That's why it is NaCl. Make sure it's the right capitalization because they're symbols. Naming ionic compounds. You do not use a prefix with naming ionic compounds. That's only for covalent. When you write the name of an ionic compound, once again, you write the cation first. So we have NaF. The first element stays exactly the way it is, sodium. Fluorine, you use the root word and add "ide," so it is fluoride. Pay attention that you spell fluoride correctly. That is not flouride, it's fluoride, F-L-U-O, not O-U. Na3P is sodium, and P is phosphorus, so it becomes phosphide. Notice there is no prefix involved because we're using ionic rules. K2O, K is potassium, O is oxygen, so it's potassium oxide. Ca3P2 is calcium and phosphorus, so calcium phosphide. Notice in none of those do I have any prefixes. Those are for covalent compounds. And to remember the difference, ionic is metal to nonmetal, and covalent is nonmetal to nonmetal. All right, covalent compound names include prefixes to determine how many atoms of each element are in a compound. True. There's nothing in the ionic compounds that says how many atoms, but there is for covalent. So the name of NO, we have nitrogen and oxygen. So we use prefixes. If you strictly use prefixes, it would be mononitrogen monoxide. But you never start a compound name with mono. So you drop the mono and it becomes nitrogen monoxide. Okay? CCl4 is carbon and chlorine. Oh, for nitrogen and oxygen, notice those are both nonmetals. Carbon and chlorine, those are both nonmetals. So one carbon is monocarbon, but you can't start with that, so it's just carbon. 4 is tetra, so it is carbon tetrachloride. We have P3S8, so that's phosphorus and sulfur. The prefix for 3 is tri. The prefix for 8 is octa. So it is triphosphorus octasulfide. Okay? Writing formulas of covalent compounds. So here is the name. The name has a prefix. If you're talking nonmetal to nonmetal, like nitrogen and oxygen, those are nonmetal to nonmetal, to figure out the formula, you just look at the name. There's no oxidation numbers, no periodic table. Nitrogen means only one, so it's N. Pent is 5, so it is NO5. Sulfur tetrachloride. Sulfur 1, tetra means 4, so you have 1 sulfur and 4 chlorides, which is the Cl. The formula for CO, oh wow, typo. I said, what is the formula for CO? And then I give you names. We'll try to avoid those. I went through it last period, we didn't notice that. So we have 1 carbon, then we have 1 oxygen, so carbon monoxide, not monocarbon, because it can't start with mono. All right, mixed stuff. Ionics are always metal to nonmetal, and covalents are nonmetal to nonmetal. MgS, look at the periodic table. Mg is magnesium, which is a metal. Way over here, S is sulfur, which is a nonmetal. Because it's a metal to nonmetal, it is an ionic compound. That's the only way that you know that. Aluminum chloride is a metal to nonmetal, so it is ionic. Nitrogen dioxide, there's 2 ways to know it's covalent. One, it has a prefix. If there's a prefix in the name, it's covalent. And then nitrogen and oxygen are nonmetal to nonmetal. That's your double confirmation that it is covalent. The formula for aluminum phosphide. So here I didn't tell you if it's ionic or covalent, so you have to figure out which rules to use for formulas. Aluminum is a metal, phosphide is a nonmetal, so this is metal to nonmetal, which is, okay, there we go. metal to nonmetal is ionic. So the formula is you're going to have to figure it out with the oxidation numbers. So we have Al3 plus, and I get this from the periodic table. And phosphorus or phosphide is 3 minus. I got that from the periodic table. You only need one of each because they have the same charge, so that's why it's AlP. The name of the following compound, PO2. P is phosphorus, O is oxygen. Those are two nonmetals, so you use covalent rules. One phosphorus is just phosphorus. Two oxygens is dioxide, so it is phosphorus dioxide. The formula for calcium fluoride. Calcium is a metal. Fluoride is a nonmetal, so this is ionic. The oxidation number for calcium is 2 plus. Fluoride is 1 minus. So we have CaF, and then we bring the 2 out from the calcium down to the fluorine. So our formula is CaF2. And I know that I have to do oxidation numbers because it's ionic, and I know it's ionic because it's a metal to nonmetal. What is the formula for sulfur trioxide? There's a prefix, so you just have to write the numbers. Sulfur by itself means there's only one, so it's S. Trioxide is 3 oxygens, so it's SO3. And the last one. What is the name of the following compound? Mg3N2. Mg is magnesium, metal to nonmetal. So no prefixes because it's an ionic compound. It's just magnesium nitride. Okay? So I'm going to stop recording.